maybe in very old movies, black and white movies, you see the lady who is like doing the switchboard, connecting one telephone to the others, in the like 40s, 50s, and that was the real origin, the first product Telegärtner was using, was producing. So we invented a special outlet that when you disconnect one, it will not be disconnected the whole system.
What?
And that was very innovative and was our iPhone moment, I would say. You use the phone, you don't really care where the information is going, but actually you always have a base station. On the base station you have an antenna, and then the antenna you have connectors, and that is where we are very strong with this kind of connectivity.
So you're like actually bringing something new to the world, and you are also expecting the world to adapt to it and to create the devices around this product?
Yeah, that is the big challenge. Yeah.
Welcome everyone! Today we have a special guest, Mr. Wäller from Telegärtner. Mr. Wäller here is the head of the Coaxial Division, and today we're going to talk about the RF connectors. Mr. Wäller, what does it mean to be the head of the Coaxial Division at Telegärtner?
Yeah, I mean, Coax connectors has been part of my life since the last 30 years, so I'm actually working with Telegärtner for a very long time, and since those early young years when I was still having black hair, I was dealing with the connectors, so they're really part of my life, and so I really appreciate that I have this job and I enjoy it a lot.
Is it true that the coaxial connectors or coaxial division was one of the first that Telegärtner had?
Yeah, absolutely. It was already starting in the late 50s. We already started producing the first coax connectors. You can see the BNC is a very classic connector, bayonet coupling connector. And this was at a very early stage we started producing that. But actually even earlier we started producing telephone switch plugs. That was the real origin of Telegärtner as a producer of connectors.
Is it this connector that we today know as the plug to the guitar amplifier or something like that?
It looks a bit like that, yeah, right. But maybe in very old movies, black and white movies, you see the lady who is like doing the switchboard, connecting one telephone to the others, in the like 40s, 50s, and that was the real origin, the first product Telegärtner was using, was producing. Yeah.
Telegärtner was invented in 1945?
Yeah, the company was founded in 1945, but it started with like the owner, the original founder, Mr. Gärtner. He started repairing telecom equipment, and that's how the whole thing started in the beginning with a very small company, 1, 2, 3, first reselling and then gradually getting into producing connectors. So it was always about communication, connecting data voice in the beginning. It was more like voice, telephone, and later the data transmission came on it. So it was, from the beginning, it was about transmitting data in a way. So that is the sort of the DNA of Telegärtner also.
Transmitting data.
In the beginning it was more voice, which is kind of data too, and nowadays of course it's more everything digitalized.
Was there any like special product that paved the way to the Telegärtner that we see today? Like maybe some that opened?
Yeah, absolutely. There was actually one product that maybe was just designed before I started with the company, which is a long time ago. But at that time, when you had a computer network, all the computers were like in one row connected. Yeah. So if you would disconnect a computer at one point, the whole network would stop. So we invented a special outlet that when you disconnect one, it will not be disconnected the whole system. What? And that was very innovative and was our iPhone moment, I would say.
I actually remember when we had those. Is it like the Viper kind of, that they are kind of the ones that can tap into the wire that is going through, and if you want to connect to the internet or to the hub, you could just like tap into the wire, and this is how you're going to connect?
I mean, at that time, basically it was a coaxial connection still. The computer was connected like a 10-base-2 technology it was called. And normally it was all, one computer to the next, to the next, to the next, to the next computer. And we created some wall outlet really similar to the telephone outlets, which you kind of can disconnect one and the main connection remains.
RJ11?
Yeah. No, it's not RJ11, it's called EAD. It was a special Telegärtner design at that time, also patented, so we were really, it was really a great product for us. And we grew, from that point we grew a lot, and we invested more money in more technologies, in RG45, in more Coax connectors, and yeah, it was one of the really big moments, I think, in the history of Telegärtner for having invented this product.
What was the name of the product?
EAD.
Yeah, this is the EAD. Okay.
Yeah, it's like make before break. That was the kind of the slogan at that time. I mean, it's all history now, but I mean, this was really important for us now. Of course, it was followed by a lot of more milestones that we're having now. For example, I'm now more in the Coax division, as you know, and one milestone in my personal career was that we are part of the designers of a new series, which is now a global standard, like the 4310 connectors, which is now used in mobile communication. And Telegärtner, together with 3 other European manufacturers, we designed this, brought it to the IEC, becoming now a world standard, and the whole world is now using this kind of connector. So for me, personally, this was my personal big moment, I would say.
So from Telegärtner started with a company just like started with fixing some telecommunication devices, and then it grew to started to make their own connectors. Then we have the EAD. Then
mobile communication exploded at some point, you know. When I was starting, nobody had a phone yet. And then gradually the mobile communication was a whole new market. And there, of course, RF connectors, coaxial connectors became a big topic. And that was another big growth scenario, of course, for us. And that's right when I joined the company. So Coax became a big thing also for Telegärtner.
What would you say the mission of Telegärtner today?
We consider ourselves as the sort of architects of connectivity. So it's all about connections, but not in terms of power or anything like that, but always communicating, helping the communication via connectivity, transmitting data via fiber, via coax or twisted pair. So we are using all the technologies, but the key know-how that we're having in RF, you know, in high frequency technology, that is sort of our core competence. So we are combining sort of this electric RF skills with the electromechanical and mechanical skills, bring this together, and that's, I think, what our reputation is built on.
Yeah, so when people are hearing that in the system they have a Telegärtner connector or Telegärtner product, what do you think they associate with? Is it with reliability or?
Yeah, I think that's what I hear when I visit customers. I mean, maybe they want to be polite, but I think basically they are being honest people and saying, yeah, when Telegärtner has, you know, we can rely on. It's a good quality product. It's a very solid company, and yeah, I think we get a good feedback normally when we talk to people using our products.
I think this is why also TME is cooperating with Telegärtner, because of the high quality products and the reliability, and that the clients want products from Telegärtner, and that's why we include it into our offer. And I think our cooperation between Telegärtner and TME started not so long ago.
Absolutely. I think it's only a few years ago that you took us into your program, and we're very happy to grow together with TME, of course. I mean, TME is a very dynamic company. It's growing fast. It's very motivated staff, and what we like also, it's very uncomplicated, I think, to work with you. You know, it's not piles of contracts that you have to sign. It's, you know, it's easy communication. You agree on something, you do it, and you keep improving on the way, but it's not like you have to negotiate 3 years until you can sell the first connector. I think this is very fast moving, and we really like this spirit of TME. And
yeah, we also believe that the cooperation is what will bring better things and better future later, and also for the clients. Well, you just said that there are some the way that we cooperate and work together, the Telegärtner and TME, that it is very open, that you don't have. Are there any other things that you value? You have just visited our warehouse in the logistics center in Lvov. How is your impression?
Oh, it's fantastic, of course. It's really state-of-the-art, very modern, very future-oriented, and I mean, that's the partners we are looking for, who are having really, I mean, you're the specialist in logistics and bringing the product very fast worldwide in the right time, in the right size, in the right quantities and so on. And we rather want to focus on doing the best connectors in the world. That is, of course, our target. And when you want to be the world champion, I guess, of bringing the product to the customer, and all together with the quality of the product and the service that you can provide, I think at the end, the customer will appreciate to have the product and the service around it.
So let's get to the product, to the RF connectors that we have here.
Yeah, how many hours do you have time?
Hours, 0.01
Okay.
hours.
Yeah, I mean, coaxial connectors, I mean, often in my private life, when people talk to me, I try to explain what we're doing, and it's a professional product, of course. In private life, you don't really get to know so much, but you can see it is, even I try to impress my daughter usually with having a gold-plated connector, which is very nice looking at. So,
is it really gold-plated?
Yeah, it's absolutely.
It's not brass?
The body is brass, but it's plated with gold, because with gold you have a special characteristic. It has a good performance in electrical conductivity, and it is very resistant to against environmental issues and so on. So the smaller the connector is, the more important the plating gets, of course.
The smaller the connector, the more important the plating.
Yeah, because the contact area is very small on small connectors, so you're relying on a very few millimeters of contact area, so there shouldn't be anything contaminated, and gold is very stable, so even after years and tens of years it will remain the same quality. That's why gold is very expensive now, but still it's used on the small connectors. But of course such big connectors like this is the 4310 that I mentioned earlier, of course in such bigger connectors it would be too expensive to use all gold.
Yeah, okay.
So this is a typical connector. You very much of your data, when you have a phone call every day, I think many times your data will run through a Telegärtner connector like this, because this is the kind of connector you connect to the mobile base station antenna. So normally you use the phone, you don't really care where the information is going, but actually you always have a base station. On the base station you have an antenna, and then the antenna you have connectors, and that is where we are very strong with this kind of connectivity. So yeah, this is from small to big, and violet coupled connectors. This is a very classic one, but it's still used so much in all kind of industries. Maybe in few use measuring equipment you will run most likely.
Yes,
BNC. One like that, BNC is maybe the most well-known. But we have a big catalog, I make like this because, paper catalog is very big, but nowadays, of course, everything is online, but we have, I think, more than 4,000 different connectors. We do customized, but also standard products. And so the customer should find everything you need for professional coaxial connectivity. We should try and find that Telegärtner. That is our goal, to offer not only 10 high runners, which is selling well, but we want to give the broad range for our customers to have a one-stop shopping and get everything they need from us with our premier quality, of course.
Yes. And could you tell me how the process of creating a new connector or making one, how does it look like?
Well, actually, that is what's interesting for me personally on the coaxial connectors, because it's on the one side you need electrical performance, RF technology, and on the other side you need also the mechanical characteristics. So it's a combination of a lot of mechanical skills, how to make the connection, and the RF knowledge, and bringing that together in the company. This is sort of our core competence. So normally when we do a new design, we specify what the parameters are, which frequency is it used for, which power should be transmitted, is there any special requirement like passive intermodulation, which is a critical parameter in mobile communication. So of course we're doing all the specification from product management, and then we talk to the customers, of course, if it's customized, what do they need, not over-engineer, but provide the perfect quality. And then of course we have a department, a lot of engineers, RF engineers, mechanical engineers. We do the prototyping, we test it in the laboratory, all features, electrical, mechanical, environmental parameters. Yeah, and if everybody's then giving thumbs up, then we start producing it in series.
How long does something like that can take?
It depends. I mean, mostly if you have a standard interface, then the front side of the connector more or less is defined, and then it depends, is the customer, do we have a special body, a special cable that needs to be adapted. So typically I would say the development takes between 6 weeks and 3 months, depending on the complexity and how much is new to the connector.
So I thought maybe a year.
Well, if you do a completely new series like the 4310, then you're right. Then there's a lot more things to be considered. So we did also a series that only Telegärtner designed, which is also now became an international standard, like the 2.25 series. It's allowing the IEC, and it's widely used in the US already. So this kind of connector, of course, it took a bit longer because you'd have to do a lot of testing, to have the interface ready to become an international standard. So in that case, it's more like 1 year or 2 years of development time.
So you're like actually bringing something new to the world, and you are also expecting the world to adapt to it and to create the devices around this product?
Yeah, that is the big challenge. You don't always succeed. We also did some series which the world didn't accept, but we did now. I think this was very challenging. It's maybe the second milestone of my personal career life. Actually, it's only designed by Telegärtner, and it's now widely used in mobile networks also.
As you mentioned previously that there are like 10 top runners connectors that we are saying. Are there more popular connectors than others?
No, it's not just 10, of course, but I would say, of course, like in most portfolios, you have a certain
Gaussian
distribution curve. Yeah, sure. And so I would say maybe 300 or 500 products probably make for the 80% of the turnover, and then the other ones. But you should still have the other ones because you want to provide the service and the full possibilities to your customer.
Right, and it is actually better to have more of the connectors in order to have the same connectors from one family in the system, because sometimes you don't want to mix them, or is it it's what makes the big variation, of course, is that you have a lot of different cables. So maybe the front size is always similar, but you have various sizes of cables. You have a straight, you have an angle, you have something going to a housing, you have something going to a PCB, and that combining all those features in all the variation that makes up to have this wide range that is necessary to provide a good portfolio. Can we mix materials? Sometimes maybe can we use brass together with other material, or does it make sense?
Well, basically most of the parts are brass. As a base material, unless you have like a contact material, then you need a very high elasticity or like high contact pressure. So for that, more sophisticated materials are needed, like copper beryllium or special alloys that give you a very good contact spring pressure. So it's maybe 5-6 different base materials that we're using. And on the plating side, of course, depending on the application, for example, there's for harsh environment or like very salty area, there's special platings that are very resistant to salt because from the sea there's a lot of salt in the air, and if you use it on ships for those applications, of course, we have special platings which are more resistant to this salty environment.
If I'm looking for a connector, what are the parameters that I should concentrate on when I'm choosing one? Of course, depending on what I'm doing, but
Overall, I mean, there's a couple of electrical parameters. Of course, the frequency is very important. What is the maximum frequency you want to run on? That is kind of limiting or saying certain connectors are more suitable. And then if it's a cable connector, of course, the cable is very dominant. If it's a very big cable, you probably don't want to use a SMA with a 10 or 15 millimeter thick coaxial cable. That will be mechanically a big challenge. It's possible, theoretically, but maybe you shouldn't move the cable afterwards. So of course the cable very much depends which series it is. So if it's used in the outside, then of course it's preferable to have a screw type connectors because you have a better sealing. If you want to have a very quick connection, if you want to very often disconnect, then a BNC or even a push-pull connector would be very good, to have quick. So it really depends on your application. So there's not like one answer, but we normally have like 5 or 10 typical parameters you should define: frequency, return loss characteristics, environmental characteristics, what kind of cable, and what power are you transmitting. So these are a little bit the main parameters you should consider when you choose a correct connector.
Okay. Probably impedance is one very important thing in this.
Well, impedance is defined in each series, so most of the connectors have a 50 ohm impedance that is called sort of the standard, because the cable and the connector have to have the same impedance. It's Otherwise, you have big reflections, and the signal will be reflected to the sender, and then you will not reach the point where you want it to be in an antenna or otherwise. So that is a bit sort of the art of the connector designer, to keep the 50 ohm impedance on each part of the connector at the same level and having a very minor deviation to 50 ohm. That is making out the electrical quality of the connector, basically. That is what needs to be done, and that's what the RF connectors are simulating with special tools to get the right mechanical dimensions to always maintain the 50 ohms within a connector and between the connector and the cable, of course.
This is 50 ohm, let's say?
Yeah.
And this is also 50 ohm?
Exactly.
Wow.
You thought this is more because it's bigger?
Well, actually, what will be the difference between 75 ohms and 50 ohms?
Basically, the impedance is defined by 3 parameters. Always, the basics is very simple. Later it gets complicated, but the basic is very simple. You have the diameter of the inner conductor, then you have the inner diameter of the outer conductor, and then you have a material in between, which we call dielectric. And those 3, there's a complicated formula. I will not go into details, but with this formula, you always can, with these 3 parameters, you can define the impedance. So if you change one of the parameters, for example, you see this is a very small connector, so obviously the inner conductor is much smaller than here, but you still want to have 50 ohm between them, right? Or always have the same. So you also need to adjust the outer diameter, or you adjust the dielectric in between. In tuning those 3 parameters, you always try to keep the 50
But you
ohm.
have some like restrictions, you have some standards that you have to follow. This is the standardization.
Of course.
And
yeah. I mean, in the interface, of course, always the 50 ohm is defined. So that's why, otherwise they would not fit together. I mean, hopefully everybody buys a Telegärtner connector, but in many cases, of course, it should be connected also from a competitor. So, of course, everybody has to keep the same interface specification. And in this interface specification, it is designed to have this 50 ohm straight. Always, yeah, that is.
Was there maybe a connector that someone told you, please make this one, and you believe that there is no chance that we are making something like that, it's not going to work, then you tried and you just, okay, it's actually working?
Yeah, I mean, one product I can think of that was a big challenge, and we succeeded at the end. That's maybe why it's a good example. It's not always succeed. But we had an inquiry once from an antenna manufacturer, and they wanted to have a connector with an integrated filter who's filtering out certain frequencies. So it's not just a connector, but it's sort of a combination of a filter, an RF filter, and a connector. And this was very challenging because there were price limitations, there were size limitations. To design this was a big challenge, but at the end we succeeded and we sold huge amounts, and I think again many of the mobile antennas maybe that you see around are having this product inside. Yeah.
So actually the RF connectors are not only in the base antennas, or we can also see them in everyday life, or because right now with the drones and
oh yeah, I mean yeah, that is of course a market which is also driving, of course, the coaxial industry to some extent nowadays, because the drones, of course, mostly they are controlled with RF signals. So you will have a ground station and you have a drone with antennas. You have to communicate via an RF signal. So, of course, also coaxial connectors are used in this application, like drone jammers, for example, where you're trying to, if a drone is coming maybe from not so friendly side, then you can jam their signal and transmit a disturbing signal, for example, to bring down their drones. These are typical new applications that also RF connectors are used in.
But not only in drones, also other applications.
Well, of course, in communication. I mean, RF connectors are, I would say, to a very large extent, they're somehow involved when you have an RF signal, like an antenna technology, because somehow you have to get the signal from the transmitter to the antenna, and in between typically you have a coax cable, a connector. So wherever you have a wireless communication, coaxial connectors are in use. And that can be also not only in military applications, but you can have it everywhere. For example, we have leakage detection systems sometimes when you're detecting some water leakage in water pipes.
What?
Yeah, this is also one of the typical, not a typical application, but something maybe which is visualizing a bit the possibilities of such kind of technology. And you know, like imagine you have a sensor which is detecting by some noise if there's a water leakage, and then a signal is transmitted somewhere and saying, hey, look here, the water pipe is losing water. Water is a precious good, so better go there and fix the water pipe. So this is just one small example, and there's multiple applications that you don't think of, but where coax connectors are actually used. Yeah.
What would be your advice for young engineers that want to design some RF systems when they are starting and they want to make it last as the connectors from Telegärtner? Any advice?
Well, maybe one advice would be don't be discouraged early if somebody tells you it's not possible. Keep trying, and sometimes it works and you get to something completely new, something innovative. Don't be discouraged too early. Try and find your way.
Okay, guys, thank you very much for watching. You will find more information on how to assemble cables and how to treat those connectors properly on Telegärtner, also YouTube channel. And for Telegärtner RF connectors, you can find on our website. Team, to you. And thank you, Mr. Wäller.
Thank you, my pleasure.